Hi, today I'll present LocateAnything3D, Vision Language 3D Detection with Chain of Sight. This is joint work between University of Illinois and NVIDIA. Foundation models today are remarkably strong at text and image reasoning. Large language models can solve Olympiad-level math problems. Vision language models can describe complex scenes or generate step-by-step plans from a single image, all with little to no effort. But when it comes to 3D perception and embodied control, the story is very different. Even frontier models fail on simple physical tasks like clean up this table. And when we ask them to estimate 3D coordinates of objects in this scene, they produce obvious mistakes. Notice all three objects share the same Y coordinate, which is clearly wrong. This reveals a fundamental gap. Foundation models are intelligent in text and images, but not grounded in the physical world. They lack embodied intelligence. Teaching 3D detection to these models is hard. There's a shortage of data and no learning paradigm to elicit 3D reasoning. We draw inspiration from two directions: chain of thought prompting, which encourages step-by-step reasoning in language models, and 2D perception recipes from Eagle and Quen, which show how to teach grounded perception inside VLMs. Our solution is LocateAnything3D, which casts 3D detection as next token prediction through what we call a chain of sight sequence. The model takes a single image and a text prompt as input. And it generates high-quality 3D bounding boxes across driving scenes, indoor environments, and tabletop settings. The key idea lives in the decoder, which follows a hierarchical chain of sight curriculum at 3 levels. First, inner object, we decode near objects before far ones. Second, intra-object, we decode the 2D box first, then lift to 3D. Third, intra-3D, we decode location, then size, then rotation. This mirrors how humans perceive. We localize in 2D first, then infer distance, size, and pose. Here are some representative predictions. The left of each pair shows projected 3D cuboids on the input image. The right shows a bird's eye view on a 1-meter grid. The turbo color map encodes depth. The model handles occlusion and truncation and maintains scale and orientation consistency across repeated objects, visible in the multi-car and multi-person examples. On the Omni 3D benchmark, LocateAnything3D achieves state-of-the-art results. We outperform imvoxelnet, which explicitly uses 3D voxels, and detect anything 3D which trains on a larger dataset. Crucially, we even beat DetectAnything3D when it's given ground truth 2D boxes as input. This shows the benefit of treating 2D grounding as a first-class step inside the model, rather than relying on external detectors. We also evaluate zero-shot generalization on novel categories never seen during training. LocateAnything3D delivers the strongest zero-shot performance on all 3 splits, while competing methods depend on an external detector, grounding dyno, to supply 2D proposals. This validates our motivation. Predicting 2D and 3D jointly transfers better to unseen categories than lifting from external boxes. A key design choice is the serialization strategy. We compare our interleaved chain of sight, where 2D and 3D tokens for each object are produced together, against a clustered alternative, where all 2D boxes come before all 3D boxes. On Objectron, which has only 1 or 2 prominent objects per image, the gap is small, just 1.5 points, since association is trivial. On Kitty, with more objects spanning a wider depth range, the gap widens to 4.7 points. And on Hypersim, chaotic indoor scenes with dozens of objects and heavy occlusion, the clustered strategy nearly collapses, while interleaved chain of sight still works. The takeaway: interleaving is essential for cluttered scenes. Here are more qualitative results spanning indoor and outdoor scenes: kitchens, living rooms, highways, and city streets. The model generalizes broadly across domains. Chain of sight also accelerates learning. On the left, our method is significantly more data efficient than a pure 3D variant without chain of sight. On the right, 2D pre-training further boosts convergence. Together, these curves show that chain of sight provides a strong inductive bias for 3D perception. To summarize, LocateAnything3D introduces chain of sight 3D reasoning inside a vision language model with a joint 2D and 3D interface, a 3D-aware curriculum, and unified benchmarks, achieving state-of-the-art 3D detection and grounding. Thank you.